the depth of what statistics spends a whole lot of time on, what many statisticians worry about. We're now ready to talk about what you do when you have samples as opposed to populations. Okay, notice when you just did that z-score formula, and it wrote it with mu and lowercase sigma, by the fact that it used the Greek letters, does that mean we were talking about a whole population or a sample?
Population.
We were talking about the whole population of something.
I hate the Greek.
They were brilliant, though.
Okay. So therefore, today and next class we're going to be talking about samples. You cannot use, gentlemen, Luke, this is critical because this is a mistake people make. You cannot use z-score information like this. You can't just go calculate. If you're talking about a sample, you cannot use this formula on a sample. Cannot use this formula for samples.
Do we not use our handy-dandy table?
Okay, we're still going to use our handy-dandy table to look up data about the normal distribution, but you are not going to be able to find a z-score by this method. Okay, so you cannot use this. What you have to understand is what we're trying to find. We need to know what a confidence interval is. When you hear on the news, particularly if it's this works really well when I'm teaching this and it's time for an election.
Yeah.
Because you're hearing them always on the news, always these political polls, and when they say there's they got some result and there was a margin of error of 4%, what's that mean?
It could be.
So, like if they said this candidate was at 52% and the other guy's at 48%,
They could be.
with a 4% margin of error,
They could be equal or even
they could be equal or they could be farther apart. There's 4% error in there either way. They count that error. Yeah, it kind of depends on where it could be. So if they're that close and it's 4%, you can't really say one's ahead of the other. Confidence intervals are how they come up with that data. The actual confidence interval would say there's a chance he falls between this number and this number. So what you're going to do, I'm going to give you the formal definition. I'm pretty sure I asked you this somewhere. What they try to do in order to create this interval of where they think the results fall is the only thing you're going to have is you have your sample data, which is what you all are going to have out of your stat project. You're going to have sample data. You're going to, in that project, make me a confidence interval. You're going to tell me your sample mean came out to be this. The mean of all your scores you got came out to be this number. But then you're going to calculate a confidence interval and say, well, that means the real mean is probably somewhere in this range, because the chances that the whole population has the exact same mean as what you get out of the sample is very slim. That'd be incredibly rare. So we're going to try to come up with an interval on either side of our sample that says, we're pretty sure the mean's in here. So it says it's an interval about the sample mean. Which symbol is the symbol for the mean of a sample? Nope. Yes, X bar, there you go. So an interval about the sample mean in which the population mean lies within a certain level of confidence. Okay, how we're going to express that confidence, they're going to say they want to be 95% confident that the real mean is in this range, or we want to be 80% confident. 35% confident would be so non-confident it wouldn't be valid to use it. 80% is about as low as we go. So they're going to have to say, if they say they want to be 99% confident, that means they want to be really, really, really sure that the population mean is somewhere in here. But what do you think that's going to do to how big your interval is? Expand it. The higher, more confident you want to be, the bigger your interval's got to be in order to get it to make sure that it falls in that range. If you don't want to be so confident, then your interval can be shorter. But it varies. That's why that when they say what percentage confidence it is, that really affects how big this interval becomes. So, actually, should have written that there. What you're going to do is we're going to know the mean of our sample. We took our sample, we got a mean. You are going to have to figure out, the symbol is E, but you have to figure out what's called the margin of error. You got to figure out how much error could be involved in this situation. So E is margin of error. And that's our goal at the moment, to figure out how do I calculate margin of error. Okay. So, you want this down. There are 3 steps to finding a confidence interval. You're going to do these 3 steps every time. Okay, this first one's kind of weird. They call it, well actually I'm writing it out in the terms that make more sense as to what it is, but they have a shortcut name for it that's a bit misleading. I don't really love it, but that's what they call it. You're finding the standard deviation of the sampling distribution. Okay, in our case, we only know normal distributions. I haven't had months to teach you all the different stats, and that there are binomial distributions. There's a number of different distributions. So right now we only know normal. Okay, what they call this though, to shortcut it, they don't want to say standard deviation of the sampling distribution. That's too long. It's more well known as, it's called the standard error of the mean. Statisticians don't always pick the most convenient terminology. No, they're not dumb. You can't call them dumb.
Not smart either.
Okay, so what it is it's the standard deviation symbol, but we're finding how much the error, standard error of the mean, so they put the little mean symbol as a subscript. So that tells you you're finding a standard deviation, but it's based on the sample mean. It's not based on the population mean. Because we don't know the mean of the whole population. We've just done a sample. Yeah. So this is the symbol for standard deviation of a population. But we don't know the mean of the whole population. We are using the mean of the sample to help us find this standard deviation. So
is this to find standard?
This is step 1. This is how to find standard error. This is okay. How to find standard error? Then there's a formula. To calculate standard error, you take standard deviation and you divide by the square root of how many items you sampled. N is how many you sampled. So you try to take the standard deviation divided by the square root of how many you sampled. Okay, but sometimes you won't always know the standard deviation of the whole population either. You are allowed to do, you may use the standard deviation of your sample if you, it can be that formula, if you sampled 30 people or more. If you're allowed to use the standard deviation off your sample. Now I will talk you through one of these in a minute, but we just got to get the steps down. So you're going to discover virtually every problem you do today, you'll have to figure out standard error. That's
So
going to be
that's one to find the confidence.
yes. Okay. Second thing is find the margin of error. Margin of error is represented with a capital E for error. Okay, and this is where it matters what percentage they say they want to be confident. I was just talking a little bit ago. If they say they want to be 90% confident, then that means you need to find the middle 90% of the normal curve. If they want to be 99% confident, then we're talking about the middle 99% of it. Okay. Consequently, won't the z-score for these lines change based on how confident I want to be? So your z-score is going to determines how confident you are. The formula calls for you to take the z-score for whatever level of confidence you're after, whatever percent you're after. You take that z-score and you times it by the standard error. That will give you the margin of error.
How far away are you from getting on log test?
For log,
Okay.
how's your Christmas present gonna be?
Log test?
November should be tamer. Okay, then last but not least, you find the confidence interval. And to do that, the error is how much you can be off your mean. So you're going to take your mean that you found from your sample, and you can be off by, say the error comes out to be 5. That means you could error 5% on either side, so you're going to add or subtract that error to your mean. Take my sample mean and go on either side. That's an E. Error.
So what's this step one?
Okay, by the way, you don't have to memorize these formulas. I will give you these formulas. I won't tell you the steps, but I will list standard errors calculated with this formula.
What it has to do with finding the confidence interval. Is that like the question I
The standard error came in right here. You took it times your z-score. That's where it comes into play. Okay, so let's actually try one here. You went out and you weighed 36 wrestlers. These must be high school wrestlers here. You went out and you weighed your wrestlers, and you found out that your mean weight was 136.4 pounds. Because you know wrestlers are always trying to take weight, meet weight, and they're always trying to
cut weight, yeah.
They want to be in a lighter weight class and be as heavy as they possibly can be, but still fall in that smaller weight class. So they're oftentimes before weigh-ins trying to lose a pound or two, or just even on those days they're trying not. There's some silliness, health risk that they're trying to get weight down, but they are concerned about weight.
Not if you're close to weight.
Not if you're close to weight, it's no big deal. Standard deviation for these wrestlers was 4.1 pounds. Oh, well, it was 14.1 pounds. Change that. Okay. I want you to find an 80% confidence interval. So we're not shooting to be super confident here. You're finding a confidence interval for the mean weight of all high school wrestlers, meaning that's your population. Okay. So you have to go through the 3 steps. What was the first step?
Find standard deviation.
Yeah, so in other words, shortcut standard error. It was the formula that said do standard deviation divided by the square root of however many you sampled. So what was our standard deviation? 14.1 over square root of how many people did we sample? 36. 14.1 divided by the square root of 36 is, that's just divided by 6, comes out 2.35. Okay, that's the easy part. Actually, none of this is that hard if you just know the steps. Okay, what's the second thing we gotta calculate?
Margin of error.
Margin of error, which is the z-score times the standard error. Okay. We already know standard error is 2.35. Okay, a z-score for what? Where am I getting a z-score?
That's the 80% confidence.
That's the 80% confidence.
So your overtime.
Ooh.
The money.
Okay. Yeah.